Okay, in number 12, we need to use a Maclaurin series for e to the x to approximate the value of an integral. So the integral we're trying to approximate from 0 to 1, e to the square root of x dx. So the Maclaurin series, remember that the Maclaurin series for e to the x is as follows. So it's from n equals 0 to infinity x to the n over n factorial. But since we're just going to be using the first three terms, let's just write out those first three terms. So remember, this is going to be 1 plus x squared over 2, because 2 factorial is just 2. So those are the first three terms we're going to be using, and we need to approximate the value of this integral. So e to the root x is a function that you can't take the integral of, at least not by methods you've learned before. So what we're going to do is replace those with those three terms from our Maclaurin series. So if e to the x is this, maybe just continue that on there, e to the root x is just if you had substituted square root of x for x. So this one is going to be 1 plus square root of x plus x over 2. So essentially we're just halving all the powers. Now even though we can't take the integral, or we can't integrate e to the root x, we can certainly take the antiderivatives of these three terms, or infinitely many if we really wanted to. And that will definitely give us an approximation. So when we take the antiderivatives, so again here, let me rewrite this real quick. We're essentially taking the antiderivative of those three. Again, it said just because we're using the first three terms. So when we take the antiderivative, we're going to get x. So this is x to the 1/2. So remember, using your integration rules there, we raise the power by 1, divide by that new power. So that's going to be 2/3 x to the 3/2. And here we're going to get plus x squared over 4. And we're taking this from 0 to 1. So you can see here that if we plug in 0, we're going to get 0. So we don't really need to do that. We can just plug in 1 here. When we plug in 1, we get 1 plus 2/3 plus 1/4. So all that's left is to combine that into a common denominator and figure out what that is. Common denominator here would be 12. So we're going to be getting, this numerator would become 8 because we need to multiply by 4. And the last one would become 3. So I'd change all these numerators to what they would be divided by 12. Put them all over 12. Here we get 23 over 12. So even if there are integrals that are of functions you otherwise would not be able to do, translating it to a Maclaurin series can help you figure out an approximation for the value of the integral.